So we're gonna try to build the first circuit here. Exciting times. I'm starting where I left off last video, which means there is a Raspberry Pico, it's plugged into my computer, and I have connected the 3 volts, mind the schematic, I will put it back underneath. The 3 volts is going to the red little line, and the black one is connected to the ground and takes this line over here. What we will do now is we will add a little LED light on our breadboard. Keep in mind, this is the little LED light and it has a longer and a shorter leg. The longer leg is the plus, right? So that's when we need to be connected to a plus. Why is this? This is a light emitting diode. That's what LED stands for, which means it's a diode which emits light if you push the current high enough. What does that mean? Is that a diode only allows flow to pass through one direction. So if you plug this in the wrong way, like with the short end to the 3 volts and the large end to the ground, then this LED will not work. It won't be broken, but it will not work as well. So keep that in mind. If an LED is not turning on, check the direction. I will plug this into my breadboard in this way. Sometimes a breadboard can be a little difficult to try a different setup. Note that I've put it in 2 different rows with its feet, right? If you remember correctly from last video, the outside rails are connected like this in columns, the insides are connected in rows, which means that these 2 pins are now not connected. Now what I could do is just plug these into the power rail, but that will blow up my LED and I will need to ask a new one next class, and I would rather not do that. So you can plug it in. I've swapped it around so that I know where the large leg is. It is closest to the Raspberry Pico. And then I can plop in a little resistor. This little resistor is something you will get next class. If you haven't gotten it, please come and check me. Why do we need a little resistor before we can plug it in? It's because the flow of current in this system would be too high. That means that the current, the amperage through this system is too high and it will blow up the LED. It cannot handle so much power, right? Which means if we put in a little resistor, we can diminish the amperage. And if we diminish the amperage, then this little LED can handle it way better. So that is what I've done. I have put a little resistor in there, and now with a black wire, because it's a ground wire, I can now connect the other leg back to the Raspberry Pico, and now you can see I have this little LED which is on, which is fun stuff. What is happening? I have created my first little circuit, and this first little circuit can be drawn like this schematically. I have my plus, right? This is where we start. We go through this little bar, we go through a resistor, we go through the LED, and we go way back towards the minus. This may be a little bit confusing at first, but this is exactly the system that I have created. You can follow it as well on your breadboard. So you start from the plus, the red wire goes through this entire rail is powered. It ends up at the resistor. Can I put you any closer? Yeah, maybe. It ends up at the resistor. This resistor gives it to this little row. The row pushes it through the LED. We're now here in the circuit. And it goes back towards the black wire all the way through this column back to the Raspberry Pico, which means my circuit is closed. And if a circuit is closed, energy can flow through it, and that means that now my LED is on. If I remove any part of this, for example, I unplug this wire, that means this is no longer connected, which means that my circuit, there is a blockage here, my circuit is no longer complete, and that means that the light will not turn on. Try to follow along, try to do this as well, try to make this circuit at home and check if you understand everything. I have now plugged it in here, but I could also just plug it into the other side, that does not matter. The main advantage of plugging it in that close to the power line is that my resistor doesn't have to go as far. I could also just replace it. with a different wire. And because it's just power, I again use a red wire. I have tried to find a kit this year for you guys that has enough wires that are red or black. And this is the exact same circuit. Now my power flows through the red wire, through the plus rail, the positive rail, which I will call now. The positive rail is the one noted with a plus and on the red and a red light on the side. It flows through the resistor, through the red wire, through the LED, we're now here, and then back through the black wire, all the way through the negative rail, all the way back to the Raspberry Pico. So that is our first little circuit we have now achieved in turning on an LED.